Everyone, this is Logic Coding. Today, let's look at the very first problem on Leetcode called toSum. It's a very classical application of HashMap. But before, let's dive into what the problem is about. So we're given an array of integers, nums, and an integer target. Return the indexes of the two numbers such that they can add up to the target. And there are some information about our inputs as well. If our inputs is an array, we can ask whether the array is sorted if the input is an array, whether it's sorted, and can we use the element exactly once, and are there repeated numbers, and so on. And after that, and luckily I think for this problem it's pretty obvious. So each input would have exact one solution, and we cannot use the same element twice, and we want to return the answer in any order. Cool. Now let's look at examples. In this input, we have 2, 7, 11, 15, and our target is 9. 2 plus 7 can give us 9, so we should return the index of 2 and 7. That's 0 and 1. The second input is 3, 2, and 4. 2 plus 4 equal to 6, so we should return the index of 2 and 4. That is 1 and 2. The last one is 3 and 3 plus equal to this. Since we can guarantee that only one valid answer exists, so this problem actually can just return the result. Some follow-up is how can you come up with an algorithm that is less than quadratic time complexity. Quadratic time complexity is pretty straightforward. We just loop the array twice. We have two for loop. We explore every possibility of two combinations and output the possible combination. If we want to solve it in linear time, and we can use an unordered map to store the item and its index. So at our current I, if target minus nums I already exists, then we find that pair. In this way, we can only do one linear scan, and the time complexity will just be O(n), and the space complexity will also just be O(n), since we do need to allocate a hash map for all the elements. So with that said, let's get started about the implementation. So we have an unordered map M, where is elements and its index. And let's declare our answer as a vector of 2 with -1, and at the end, let's return our answer. Then we do the linear scan of our array for int I equals to 0, size I++. We found our target minus current number, and if my n is already encountered and stored in this M, then I just need to do answer 0 equals to mn, the previous index, and answer 1 equals to the current index. Else, there is no n found. We still need to store this number's index. Let's see. So we first get the number, and then we have two cases. Let's try run the code. Let's try and submit it. Cool. So this is a very classical example about the application of unordered map. There is another way to solve this if we do want to use save space 01, and if we want to sort the array and use 2 pointers, the time would be n log n because of the sorting. So that's another way. There is a trade-off between time and space for this question. But we have a different version for this algorithm, which I'm also going to make a video on. So stay tuned. See you next time.